So I support the Woven City product security team. So we generally support the Woven City teams with security advice at all phases of the product development process. And so today I just want to talk about kind of one of those phases, which is threat modeling. So in security, we think that preventing bugs is much better than finding them and fixing them after the fact. There's been a number of research, like this IBM study from 2010, that shows that bugs that you find and fix in the maintenance phase can cost up to 100 times more than if you can just prevent them from occurring at all. So shift left, Hunter did a little introduction. So what does that mean? That means that we move these activities earlier in the product development process. So that means security requirements, design review, threat modeling, static analysis, code reviews, testing, and of course auditing. We still need those things because even if we do all of the previous things, the security requirements and design reviews and whatnot, there will still be issues that show up in production. So what is threat modeling? It's looking at what you have and understanding what can go wrong so that you understand what the risks of your product are. And it's something that anybody can do. You don't have to be a security expert. You, in fact, are probably the best person to do this for your own code because you're the closest to it. So as a security person, we kind of think of threats coming in several different ways. And popular methodology is the STRIDE methodology. This was, I believe it was developed at Microsoft. It's heavily used there. Is used in this book, Threat Modeling, Designing for Security by Adam Shostak. And it divides this into a number of potential threats. So we have spoofing, which is pretending to be something that you're not. Tampering, changing the values of the data. Repudiation, so if I can perform an action and then say that I didn't perform an action. So that's the property we want, is non-repudiation. Information disclosure, this is your data breach, but it's also potentially losing your IP through code leaks or whatever. Denial of service, so if I can make that site unavailable, then that is also something that we might want to protect against. And elevation of privilege, can you do something that you shouldn't be able to? So that could be administrative access or being able to sort of make an approval that you should not normally be able to do. So to illustrate this, I've come up with this very simple ID verification service. It's very naive, and it probably will not work in real life, but it just gives us enough to illustrate. So what this is just a service that somebody goes to that they need to verify their ID for some reason, upload a picture of their ID to the website, we run it through a verifier, and maybe we call an external service that gives us some more information about the ID and then return that result to the customer. So when we think about threat modeling, what we want to think about is assets and communication. So our assets in this case are our website itself, the verifier, maybe those algorithms are sensitive. We don't want somebody to be able to guess what our algorithms will do. And then the database of IDs is kind of a treasure trove of information for an attacker. And then for the communication, we have a number of ways that either the user communicates with the system or the systems communicate with each other. I won't go through all of those. And so when we think about threats to this, we can kind of take that model that we had earlier and start applying it to these different areas. So for spoofing, a user might upload somebody else's valid ID, right? So we want to make sure that it's really that person. Maybe we have them take a video, we do some name matching and things like that. Maybe they want to alter their ID, right? Put a different expiration date or something on it. So we want to look for that evidence of tampering. So that's kind of the mitigations that we want to do. And then we might have a network attacker who's very sophisticated, who can pretend to be our external verifier service and intercept the the communications there. And so we want to make sure, using some technology like mutual TLS authentication, that it is the server that we're expecting to talk to. So for tampering, this is when an attacker might change the values in the database. So they might change the verification status. So they upload a bogus ID, then they realize that it's not going to work, so they change it themselves. And so maybe we want to make the database append only, right? So the web server can't actually change the values in the database except by adding new values. Similarly, tampering with the network traffic between different parts of the system, we still want to use mutual TLS. And you'll note that this kind of helps us ensure the confidentiality, integrity, and authenticity of our systems. And it kind of addresses multiple threats here. So it's always a useful mitigation. For repudiation, a user might claim that we verified their ID. So we want to log those activities and ensure that that is auditable in some way, that we can go back and tell whether that really happened. For information disclosure, we have those ID photos in the database. We want to maybe encrypt those IDs. Only the verifier can decrypt them, so that if an attacker breaches that web server, they don't have access to those ID photos. Similarly, with the verification results, we may not want to allow somebody to tell if they've been verified or not unless they're actually that user, so encrypt the database against an attacker. And finally, those verifier algorithms, those might be very sensitive for us, right? An attacker who could upload a lot of IDs to it can tell how that algorithm works and then generate adversarial IDs that can beat our algorithm. And so we want to really rate limit those ID uploads based on a number of indicators, IP, account, or other indicators. Denial of service then. So this might be somebody uploading a lot of IDs. We often think about this as sending a lot of network traffic. But the reality is denial of service can also be consuming our resources. So if we're limited on certain steps in our verification service, how quickly those can go, we might want to do cheaper pre-validation checks or do some kind of rate limiting to mitigate that. Finally, elevation of privilege. So this would be somebody maybe gaining administrator privileges on the server. So we want to log all of our activities, make sure they're patched, have proper ACLs, things of that nature. All right. So I mentioned the book earlier, the Threat Modeling Designing for Security. It's kind of the foundational book in this space. And it's a really good introduction to threat modeling. There's also this GitHub that has a lot of resources, books, videos, classes, things like that. So if you're interested in learning more, there's lots of resources out there on the internet. All right, finally, I will leave you with a picture of my cat. Thank you for listening, and I hope for any questions that you have.
So you said the verifier algorithm is kind of very sensitive to you. So when the adversary wants to identify what is the verifier, how the verifier algorithm works, or even let's say the verifier algorithm kind of decrypt your data. So the adversary tries to send some chosen ciphertext to your verifier algorithm and tries to understand the pattern of the decryption. So how can you solve those kind of issues? This is the first question. The second question is, you say the mutual TLS. Do you guys use the standard TLS algorithm that is like OpenSSL, or you use some advanced encryption algorithm like OPEC or some other authentication algorithm that's being under research or not being standardized?
Sure. So let me answer the second one first. Mutual TLS is just basically both sides have a certificate. So both the server and the client present a certificate, and the server can validate the client's authenticity, and this client can validate the server authenticity. There's still a lot of things that can go wrong there, but it's very effective and pretty well known. So rather than using something that's still experimental or unknown, it's probably better to go with something that has been well tested and looked at by security experts. So for the first part, I think if you're thinking about somebody trying to probe an algorithm and understand how that algorithm works, like generally what they're going to do is provide a lot of examples and see whether those examples pass or fail. And the way that you might test that is by seeing how long it takes to return a value. And again, you also have that information on the pass or fail. So if you can provide a lot of examples of and perturb the input to that algorithm, maybe there's an OCR algorithm, or like I mentioned, maybe we do some searches for image tampering evidence, like JPEG compression artifacts and things like that. You can kind of work out eventually what is going to pass that algorithm. So it's regardless of whether the IDs are encrypted or not.
Great. Thank you.
Yeah. I think you had a question.
So in the beginning of your presentation, I think it was slide 5, that you were discussing the whole workflow, and you were explaining that first come the design review, and then the security requirements are discussed. Is it actually forth and back communication? Because I think it might actually change a lot.
Yeah.
The whole design picture after the threat modeling.
So absolutely, it absolutely can, and that's why we want to start with something like the security requirements themselves and the design review. Like threat modeling isn't something that just is one part of the process. We can think about threats before we understand how the system itself is designed, but then when we start to look at the design itself, then more things are going to come up. So it's kind of a continuous process. And that's why it's important for developers to do this, because you can kind of keep that model up to date as you make changes.
I see. So it's will be like series of meetings between developers and the security engineers, right?
Sure. So a couple ways that you can do it. So it's something that your security team can help you figure out how to do, but generally speaking, it's for your benefit, right? So that you understand it. And
sure.
if you do it, then you will understand the model as well as you understand the design. And so it's good to have that verification, that feedback, that maybe there's something that you missed or something that isn't as big of a threat. And I didn't talk about the likelihood of attacks, which is something that is a little difficult to figure out if you don't have that specified knowledge. But in terms of what the threats are, I think that you can really understand them pretty easily.
Thank you.